Hello, good morning everyone. So today we will be solving some problems in circular motion and problems with non-uniform circular motion. So both. Okay, so let us see. We already seen the theory in circular motion 1 and 2. Let us look at the numerical problem solving approach of it. Okay, so now, so the first question that I would like to ask here is what should be the speed of the jet moving in a circular path of 1 kilometer to induce an acceleration of 3g on the pilot. So what is being given? So it says we need to find out what is the speed. So this is problem number 1. What is the speed of the jet moving in a circular path? So he is now moving in a circular path. Speed v is equal to what? He is now moving in a circular path. Okay. And then the radius of the circular path is seen to be 1 kilometer. 1 kilometer to induce an acceleration. So induce an acceleration of 3g on the pilot. There is a pilot who is sitting there, and you need to find out what is the acceleration on the pilot, and you have to make sure that the acceleration of the pilot is equal to 3 times g, and what is the speed required for the jet in order to move at a speed of 3 times g. That is, have an acceleration of 3 times g. Hope the board is clear to you. Okay. So now, so how do we do this? What is the formula that we use over here? Now, when we say the speed v is equal to speed v is unknown, which speed is he talking about? He's talking about the speed which the particle is moving like this, right? So every time the speed is same, that's why he has given only one speed over here. Okay, and thus we need to find out what is the speed. And whenever a particle is moving in a circular motion, we know that okay, we can use the acceleration is given by v square divided by r is equal to a. So do you remember what is this equation equal to? This equation is nothing but the centripetal acceleration, right? So using this equation, you need to find out the value of v. Now let us substitute the value. Let me take the value of g is equal to 10 meter per second square. And then based on this, you can now write v square is equal to a into r. Now substitute the value of a, which is nothing but 3 times g into r. Now what is r here? R is nothing but 1 kilometer. So since the value of r is given in kilometers, we need to convert it into meters, which is equal to 1000 meters. Okay. So let me substitute all this. This is 3 into 10 multiplied by 1000. In other words, now I can also write this as v is equal to square root of, I can now write this as 3 into 10 to the power of 4, or I can now write this as 3 into 10 to the power of 4, which will now be equal to root 3 multiplied by 10 square, which is now equal to, what is the value of root 3? 1.732. Oops, my pen has a problem. Just a minute. Okay, get a better pen. Okay, so root 3 has a value equal to 1.732 into 10 square, which is 100. And thus I can now write this equal to something like 173 meters per second, right? So 173 meters per second. Now, if you take 173 meters per second, what is this value of 173 meters per second will be? Let me find out that. So if I convert it into kilometer per hour, because that is the usual way of talking about. So we get this as 173 multiplied by 18 by 5, because 1 kilometer per hour can be converted into meters per second as 173 into 18 by 5, multiply that by 18 by 5. So using the calculator, I find that 173 divided by 5 is equal to 34.6, and this multiplied by 18 will give rise to 622 kilometer per hour. 622 kilometer per hour. Wow, this is really a whooping, a very high value, right? Because you know, from here to Chennai, it's around 360 kilometers, right? So if I have a jet moving at 622 kilometer per hour, which means I can reach Chennai within half an hour, right? That should be the speed at which it should be moving. Fine, from Bangalore to Chennai. Okay, fine. Now let us look at the second problem. Right. Okay, the second problem states that, okay, just a minute. The second problem states that, oh, Second problem states that a flywheel has a radius of 20 centimeters. So radius is equal to 20 centimeters. What is the speed of a point on the edge of the flywheel? So you have a flywheel. What's a flywheel? It's nothing but a metal disc, and then at the center there's an axis. So this flywheel can now rotate. There's a groove over here, and on this groove we pull it across, and then the disc starts moving across, right? So this is called as a flywheel. Okay, and now this can be mounted on a stand, and thus this will be able to rotate it. We do it for some experiments anyway. We'll not discuss that. So what is the speed of a point on the edge of the flywheel if it experiences centripetal acceleration of 900 centimeter per second square? He has given you the value of 900 centimeter per second square. Convert this into meter per second square. This will be 9 centimeter per second, 9 meter per second square, right? Okay. So we have got A, we have got R. He is asking you to find out what is the speed of the particle. So if it is at this point, what is the speed? Now using the same logic, how do we do that? Let me go back to the board. So okay, so now, so as you see, now I have this. Now I need to find the value of V. Value of V can be computed by using V square by R is equal to A. Whenever the particle is moving in a circular path, we can always use centripetal acceleration, V square by R equal to A. R V should be equal to square root of A into R. Now let us substitute the value. This should be square root of 9 multiplied by R is in 20 centimeters. Need to convert it into meters. So 0.2 meters. And thus this will now be equal to square root of 1.8. Now let us find out what's the value of 1.8. Root of 1.8. What's the value? 1.8 square root. Square root of 1.8 is 1.341. 1.341 meters per second. Right? So you can also convert the speed in terms of kilometer per hour as 1.341 into 18 by 5. So which will give you, what's the value? What's the value multiplied by 18 divided by 5? Okay, so which comes out to be around 4.83 kilometer per hour. 4.83 kilometer per hour. Wow, this is really lesser. That's fine. So this is the speed at which a wheel is now rolling across, right? Okay, so now let us move on to the third problem. I hope you are getting a hold on circular motion. Am I right? Okay, so now let us move on to the next one. So people who feel, okay, solving numericals is difficult. And you see, is it really difficult? It's quite easier, okay? It's not at all difficult. Only thing is you need to know what parameters are given in each problem, and then you can proceed further, okay? The third problem says, now see, the first problem was about a jet. The second problem was about a flywheel. The third problem is about a proton. Okay, it says a proton has a speed of 5 into 10 power 6 meters per second. Wow, the speed is really, really high. 10 power 6 meters per second. I can't even think of moving such a speed. And is moving in a circle in the XY plane of radius R equal to 0.175 meters per second. Oh, good. Bigger radius. At t equal to 0, the position of the proton is 0.175 meters and it circles counterclockwise. There is an information missing here. Anyway, let us figure it out and then start with it. Okay, let me assume some data missing here. Okay, so you need to find out what is it about. Describe the positions of the proton at t is equal to find where is the proton. Where is the proton? Where is the proton at a time t is equal to 1.1 into 10 to the power of minus 7 seconds. Wow. Okay. So now what is missing here? I said, okay, there's something missing over here. So read the statement once again. A proton has a speed of 5 into 10 power 6 meters per second. It means, okay, so proton is now moving like this. Maybe at this point, 5 into 10 power 6 meters per second. And it's moving in the circle in the XY plane of radius. So it's moving in the uniform circle. It's moving in the circle, uniform velocity. And R is equal to 0.175 meters. So radius is 1.175 meters. Okay, so we need not convert it into centimeter or anything. At t equal to 0, the position of the proton is 0.175 meters. So from where it is 0.175 meters? With respect to the origin, and I say it's at 0.175 meters, it could be at point A here, it could be at point B here, it could be point C, point D, point E. It can be anywhere. Okay, that particular part has been missing. So what we do is currently, let me assume that the particle is at point A. At this point, it is here. Okay, then the position of the proton is given and it circles counterclockwise. What do you mean by counterclockwise? Clockwise is this direction, which means it's moving along the clock, right? The way how the clocks, this one moves, it is moving along the clock. But whereas now it is in an anti-clockwise direction, that's what is counterclockwise. Means determine the positions of the proton at t equal to 1.1 into 10 power minus 7 seconds. Where is the proton at this particular time? How do we do it? So towards it. Now what is given? V is given, R is given. So therefore, now how do I find at what time, where is this particular proton over here? Now we can find this if we know what is the total time taken by the object to circle. It is like saying, for example, if we say, okay, a particle started from here, it comes back to point A in 4 seconds. Where was the particle at 2 seconds? You can exactly say it was here. Where was the particle at 1 second? It's here. Where is the particle at 3 seconds? It's here, right? That's quite easier. In a similar way, we can also do this in same way. So in other words, we need to find the value of t. What is t here? The time period. We need to find out the time period. Now in problems of this sort, okay, generally students will have a difficulty in understanding what to be found, right? It's not so easy. So therefore, now it's what to be found over here. So t is the time period which you need to find. Now, how do you find the time period? Or in other words, you should now ask the question, how t is related to v and r. Now, you know, this v and r are related to each other by omega. What is omega? Omega is nothing but angular speed. Angular speed. So how do you calculate the angular speed? So angular speed is calculated by the formula omega is equal to, is related to this as 2 pi by t, and this angular speed also given by v by r over here. So therefore, now I can now write t is equal to 2 pi r divided by, t goes upwards, 2 pi r comes over here, divided by v. You can also understand it in another way. You can say the particle is moving at uniform speed. The total distance covered is nothing but 2 pi r divided by the speed of the particle. So this you get this distance by velocity or distance by speed. Now let us substitute all the values. You get this as 2 pi into 0.175 divided by, okay, I have not shown the camera there. Okay, fine. Okay, fine. Now it is fine. Okay, right. Okay, so 2 pi into 0.175 divided by speed. What is speed? Which is 5 into 10 to the power of 6. Now let me substitute all these values and see what do you get over here. You get the answer as 2 pi is nothing but 6.28 into 0.175 divided by 5 into 10 to the power of minus 6. Okay, so now the answer should be using the calculator 6.28 into 0.175 divided by 5 is equal to 0.219 into 10 to the power of minus 6. What is the unit? Seconds. Seconds. Wow. So this takes somewhere around 2.2 into 10 power minus 7 seconds. Now I hope you would have got an idea. Okay, where will the particle be at a time t is equal to 1.1 into 10 to the power of minus 7 seconds. Can you guess where will it be? It will be at, see, the whole time, total time taken by the particle to start from point A and to reach one complete circle is this time. So in divided by 2 will be 1.1. So it will be at the diametrically opposite end, right? So the answer is it will be at the diametrically opposite end to that of its starting point, right? Okay, so we have got one more. Now let us move on to the next question. The next question is, what is the next question? We share the screen. Right. So can angular velocities be added? Can we add the angular velocities? First of all, what is an angular velocity? Angular velocity is nothing but it is the angular speed, similar to the angular speed. Only thing is, okay, it has a vector quantity also, right? So can angular velocities be added? Now, angular velocities can be added. Now, how do you depict the angular velocity? The first question we need to ask. So I had already explained in my previous lecture on axial vectors that angular velocities can be added because angular velocity is nothing but if you have a displacement of a particle going like this and you have the velocity, the velocity is going like this and the radial vector is displaced like this, then so r cross v will give you the angular velocity omega, which will be perpendicular to the plane containing this. So as you see, if this is going shown by a circle, so every time the velocity vector is always directed like this. It's always been directed along the tangent to the circle. And every time you see the radial vector is been pointing to the point over here like this, right? It's pointing to the point like this over here. So therefore, you see, the r cross v will always be a vector perpendicular, and this could be understood with the help of the grip rule. The grip rule which says that, okay, so if velocity is like this and radius is like that, then the angular velocity vector is perpendicular to the plane of the figure. So therefore, so you can add the angular velocity vectors in two velocities. So let us say, for example, I have given one torque, I have given one rotation, there is one more torque also given. So both has induced an angular velocity of omega 1 and omega 2 respectively in the same direction. Then after giving two torques, after rotating it twice, you see the total angular speed will now be equal to omega 1 plus omega 2. Now, on the other hand, if I have given one torque like this, one time I have given rotation, then I give a small force and rotate in the opposite direction, right? What happens to a disk? The disk will now slow down. When it slows down, then what happens is omega 1 will be positive, but omega 2 will be negative. Because the net angular velocity will now be equal to omega 1 minus omega 2. This can also happen, right? Thus, angular velocity can be added, right? Now, one question, what is the situation of a rotating disk when the angular velocity, net angular velocity is equal to 0? What do you understand by this? The guess is that when I say omega equal to 0, the particle or the disk is not rotating, right? Is it moving further? We do not know, because it does not describe about the linear velocity, right? So it can be moving further. For example, if I take this one, if it is now been rotating like this and also moving like this, then you can say it has an angular velocity and it also has a linear velocity. But if it does not rotate and if it is just sliding like this, then you can say it only has a linear velocity. Then now let us look at the fifth problem. So if you whirl a stone, in a circle using a string, what will be the force acting on your fingers? Assuming the fingers are at the center of the circle. So I'm whirling a stone. I have a string, I have a stone over here, and I'm holding it over here, and I'm whirling it in a clockwise direction. I'm just whirling it like this. So as I whirl it across, now what will be the force that is acting at this point? What will be the force acting at my finger? I'm keeping my fingers over here. So in that case, the force acting here is nothing but centripetal force. The centripetal force is acting at the fingers. Okay. Now let us move on to non-uniform circular motion. So here we have two more problems. The first problem says an object moves along a spiral path as shown in the figure below. Okay. So must its speed increase, decrease, or remain the same if the magnitude of this radial acceleration is to remain constant? What will happen? What do you think should increase, decrease, or remain the same? See, if it is moving in a circle, if it is moving in a uniform circular path, its radial acceleration will always be like this, right? It's changing. But what will be the magnitude of the radial acceleration? It has always a constant, because radial acceleration is given by v square divided by r. Now, what is being asked? Okay. So, must its speed increase, decrease, or remain the same if the magnitude of its radial axle is to remain constant? Now, you see, when a particle is moving in a uniform circular motion, the speed of the particle remains a constant. Radius is also constant. AR is constant. Now, here what is happening? Now, you see, as the particle is moving away from the center, the radius of the circle keeps on increasing, right? If I consider this radius, it is larger than this smaller radius. It is larger than this radius, right? So, therefore, radius is increasing. If denominator is increasing, now what should happen to velocity? Velocity should also increase, right? Velocity is also increasing in such a way that AR remains a constant, right? So whenever the centripetal force is constant, then what do you understand? The centripetal force is constant, but still the speed is increasing. And definitely the particle is moving in a spiral motion, right? So this is what you can understand from here. Okay, so the last problem, I will not do it now. Okay, the reason is because I have to give you some more information regarding the theory part, and then we will continue to focus on this. Okay, so with this, let me stop over here and mention your comments, how good it was, what was it about, what is it you expected, then we will proceed further with your comments. Thank you.